So our next speaker is Lenny Teytelman. He's the co-founder and CEO of Protocols.io, an open access platform to share and discover research protocols. Lenny has a strong passion for sharing science and improving research efficiency through technology, as he shows us today in his talk titled, Call to Reduce Random Collisions with Information. We can automatically connect scientists to the knowledge that they need.
Here we go. I will be talking obviously about protocols because that's what I think about all the time, research recipes. But first 2/3 of the talk are focused on Protocols.io, and then I will talk a little bit more broadly about what I mean in terms of the potential that we have for reducing the randomness of how scientists come across the knowledge that they need for their research. And so when it comes to methods and the randomness, just this year, there was a publication of the first results of a huge reproducibility project in cancer biology. It was published in eLife, the first 5 papers. And this is a $2 million effort to just replicate famous published studies and see how well can we reproduce the results. And one of the main takeaways, this was covered in PBS, Nature News, Vox, Atlantic, NPR, and one of the main takeaways from it was, I'll just quote from Ed Young in The Atlantic, the hardest part by far was figuring out exactly what the original labs actually did. Scientific papers come with method sections that theoretically ought to provide recipes for doing the same experiments. But often those recipes are incomplete, missing out important steps, details, or ingredients. In some cases, the recipes are not described at all. Researchers simply cite an earlier study that used a similar technique. And then what the reproducibility project found out is when you try to actually chase down what was done by the lab and get the recipe, very often the people who have done the work are no longer there. They've left academia, and now you're searching through lab notebooks trying to figure out what was done for the study. We can do a lot better. Here is another illustration of this. This is a professor blogging about it 2 years ago. It's Canadian professor Timothy Passeau. And he said that our method sections, to put it mildly, are terse. And this is basically the illustration of our, this is a meme on how to draw an owl. And he said that our method sections are essentially something like this. We draw the owl on 60 GSM white paper of the A4 dimension using 3H and 6B graphite pencils. We did so by looking at owls and drawing what we saw on paper. This protocol yielded one drawn owl. That is, in the 5 years that I've been obsessed with protocols and how we publish them, this is really accurate. As I said, this is a blog post from 2 years ago. Just a few days ago, here's somebody on Twitter, a researcher who said, looking for protocol in 97 paper, as described in X et al. 96. Finds 96 paper as described in X 87, finds 87 paper, paywall. Right? And in September, Mike Eisen said on Twitter, a few things frustrate me more than having to go 5 or 6 references deep to find details on the method in a paper. Someone asked him, and do you believe that the method being used today is actually the protocol described 4 citations deep, referring to a decade-old paper? No chance. Okay? So what Protocols.io we see as our mission is to move beyond the way we're publishing right now in the method sections to a point where instead of contact author for details or as reported in another paper with slight modifications, good luck figuring out what those modifications are, we want to have a link to the detailed recipes so you don't have to, for the people that actually want to replicate the work, who do need to see those details in the protocol, we want to make it easy for them to find it. So that's part 1 of what we're trying to do. And part 2 is what happens after publication. And how do you, when you have, particularly in methods, because they're dynamic, once you publish it, it doesn't mean that it's done, how do you correct them? How do you optimize them? So my own personal experience as a postdoc at MIT was a 1.5 years on this protocol right here to discover that this step right here is incorrect, right? So instead of a microliter of an enzyme, I needed 5 in the test tube, and instead of a 15-minute incubation, it should be 1 hour. Right? So this is a year and a half of my life. And the absurd part is this is not a new method. This is a correction of something previously published in Nature Methods. So what that means is I call the author, who is a professor in UPenn. I tell him this. He says, this is wonderful. I let everyone who asks me know what it should be. But even he cannot go to the Nature Methods paper and put a post-it on this step to say, that's wrong. You should use 5 instead of 1 microliter, right? So I get no credit for this. And everybody else who's using the same technique is either getting completely misleading results or has to waste a year or two and rediscover what I know, what I would love to share, but there is no infrastructure, there is no mechanism for doing that. So that's exactly what Protocols.io is for. Let me make it a little bit smaller. Live demos are hazardous. I'm not going to go, we've been building this for a long time. We launched it 4 years ago, so I'm not going to go exhaustively through all of the functionality, but just to show very quickly some of the cool parts of what it is. This is open access. It's free to read. It's free to publish. It's Pitt Beanfield's dream. And everything I'm showing you, this is on the web, but there's also a free iOS native app, a free Android app, for interacting with the protocols. And so, as an example, here's a public protocol. Any protocol that you create is private by default, but here is a public protocol. It is not a PDF document. These are dynamic and interactive. You have steps, you have timers inside them. Every protocol has a run button, so it doesn't apply if it's a computational method, but 90% of the methods that we have, more than 90%, are for use in the lab, right? Experimental protocols when you're pipetting and moving things around from test tube to test tube. So if you have such protocol, you can actually hit run or start it on your iPad or on the laptop, and you can walk through it as you're doing that experiment that day. So it's a cooking recipe, and I'm on step 1. Step 2, you can track any changes, record what you did differently today. If there's a timer, you start it directly inside the app. So this is just helping you perform the experiment. But one of the most important things from my perspective is that it's not just that you can run them, but these protocols are interactive for everybody who's using them in terms of being able to ask questions and have conversations and discussions. So you can, on any step, you can ask a question. On the right-hand side, you can ask a private question to the author, or you can ask it publicly so that everybody who's using the protocol will see it. And here is, on step 25, there are 2 comments. And you can see this is version 3 of the protocol. If you're the author, you have the ability at any point to create a new version. Each version gets a DOI. It's fixed. If you cite it from a paper, you cannot change it, but you can always create a new version, and people are able to very transparently compare what it is now and what it was before. And so in version 2, this step used to say, air dry your DNA pellet for somewhere between 2 to 2 minutes with a 7-minute timer. There's obviously something confusing there, and this scientist asked, what do you mean by somewhere between 2 and 2 minutes with a 7-minute timer? The question goes instantly to the author and to anybody else who's using the protocol. The author answers, whoops, this is a typo, it should be 2 to 3 minutes, and then creates version 3 that you saw initially, and then creates version 3 where this step is fixed. This is minor. This kind of stuff happens when we publish, when we share, all the time, right? This is part of the course. Every paper I've published has mistakes on it. I know that. I just don't look for them. But when somebody else finds it after you've published, you do want the ability to respond, right? So here is version 3, 2 to 3 minutes. And back in April of this year, Public Library of Science added protocols to the author instructions for all 7 of their journals, including +1. So it's a very simple thing. I know there are a lot of publishers in the room, so I want to take just a second to show how this works. So on the plus side, If you go to the materials and methods, it says we recommend and encourage, if you have a lab protocol, that instead of supplementary or contact author, that you put it in protocols.io and get a DOI, add it to the materials and methods. It's unlisted at that point, so only the reviewers and the people with the link can see it. And when the paper is published, if it's accepted, we're synchronized. We will see that there's a link to protocols.io. We push the protocol live, and we add a link back to the article. Right? So how it looks, here is one of the many examples. This is a PLOS biology paper. If you go to materials and methods, it says, instead of contact author for details, it says the methods are available as a collection on protocols.io. Here's the DOI. And if you click that, you will get all of these step-by-step protocols accompanying this paper. It links right back to PLOS biology. And we make it very clear that this is a protocol that accompanies the PLOS biology publication. If you try to cite it, we ask you to please make sure that it's not just the protocol, but the publication as well, that you cite both. So there's no reduction in the number of citations to the original publication, right? So this is bidirectional, and that's addressing that goal of moving towards more reproducible papers with protocols that are interactive, dynamic, runnable, and the reducing the part about notifications, when I said reducing random collision with knowledge, that's a key issue for me, because you could write a paper, right? For that small modification that I had, I could write a +1 paper and maybe spend half a year and try to get it out. But if you do, it's citation 473 to the original Nature Methods publication. No one knows that I've published this. And no one, when they're starting adopting a new technique, is going to look through 400 citations to see if possibly someone somewhere modified one step of the protocol, right? So what you want is this automatic, all the people who use this protocol, when a new version is created, and just as on GitHub for software, anybody else can come in and create a branch of it, clone it, and publish their version of it. Even if they're not the author, they can't change somebody else's protocol, but you can share these optimizations and changes for application in other instances. This is it for the demo. Last thing that I wanted to show. Another important part is, so this is from a +1 paper. You can add images, videos, tables inside individual steps, right? So if instead of text description, invert tube, and you don't know if you're inverting like this or like this, you can have a 10-second clip that actually shows you exactly what is happening in that step of the protocol, right? So this is, again, towards increasing the reproducibility of papers. And if I go back to the slides, this example I already covered. This is the video protocol. It's just, in my mind, this is a beautiful example of where publishing is moving. It's not a PDF anymore. We've had this come up in several talks yesterday. There's the story. That's the peer-reviewed part. It's still important. There's the story, but the story links to the dynamic protocol with videos inside. All of the code accompanying this paper is on CodeOcean, so it's runnable. With a click of a button, you can run the author's code, or you can upload your own data set and do it. So publishing is becoming a little bit more of a puzzle, right, of pieces fitting together and linking to each other. And this linking between them, that's the metadata bit that becomes very, very important in the next part of what I'm going to cover. And I should also say that when we find that a protocol links to a paper, we also update the DOI record with Crossref, saying that this is connected to the paper so that you have the metadata that Jennifer was talking about. And the last example that is probably my absolute favorite here, here's a scientist in Chile who's asking, does anybody have a protocol for getting RNA out of neuron cultures? And someone from UCSF replies, you should try this method with this particular chemical, and it brings a bell in my head that we have a few protocols out of the 2,000 on our site. We have a few protocols with this. I ping them back saying we have a few, and the researcher from UCSF says, oh, this is the one that should actually work for you. And when I took a look at this protocol, the triazole extraction of RNA, this was actually part of a GigaScience paper on parasites of stickleback fish. It has nothing to do with neurons, right? But GigaScience was the second journal to partner with us. A lot of people have been publishing there and putting the protocol. And so the impact is not just on the paper itself for the readers who are interested in that particular organism, but there is a much broader implication and benefit to the rest of the scientific community who might not be working on what that paper is, but the protocol, perhaps with slight modifications, is going to be super useful in other applications, right? So having it in a central place, open and accessible, is very important. I'll skip, for the benefit of time, the next example. And this is where we are in terms of the number of journals connecting to us. For 2 years, we had 2, Genetics and GigaScience. In April, PLOS took us to 10 journals that had us in author instructions, and that was a sea change. So once a big publisher said, this has been worked out, we can trust this makes publishing better. By July, we had 50 journals, including eLife, and recently BMJ Open added us. So at this point, I think we're at over 200 journals, which is, the graph looks wonderful, but of course we have another 26 biomedical journals to go, according to PubMed. So any publishers here that we don't, as I said, free to read, free to publish, we don't charge the scientists, we don't charge the journals. It's just mutually beneficial for the reader, for the journal, and for Protocols.io if we all link up. So, and this is just the growth in the number of people. It takes a while to create something like this and actually get people to use it. That's why it's important for us to connect with the publishers, and this is monthly number of people who are submitting protocols to Protocols.io. And so at this point, finally, we have good growth where we're getting about 100 public protocols every month instead of 5 that we used to get a year ago. And there's about 300 new ones privately that are created on a monthly basis. So we have just over 2,000 public protocols and just over 4,000 private ones today. I'll skip the business model. Find me afterwards if you want to know how we manage to do this free to read and free to publish, who we do charge, and for what. Last thing I'll say on protocols is we're focused today on those 2 things that I mentioned in the beginning, right? Making sure that the paper itself is more reproducible, and that if you find mistakes or have optimizations for it, that you can share that. That's what we're focused on today, but what this enables us in the future, what we're already thinking about, is you want to connect this to the devices in the lab, right? So as you're walking through, if you're using a centrifuge and it's set at 12,000 RPM, but your protocol step says spin at 3,000, and otherwise you're going to burst your cells, we have the technology and we have everything we need at this point to actually connect this to the device so you get a warning on both ends asking, are you sure you want to proceed? You're on step 7 of the protocol, and it looks like the device isn't set to the right parameters. So that's something that I'm excited for in the years to come. And in the last few minutes, I wanted to tie this whole thing about knowledge and what we're in position to do with Crossref and with the technology and the resources and the platforms that we have today. And just a brief word on the way to protocols. We're crazy enough because it's not hard enough to do one thing, but before we did protocols, we created a literature recommendation service. It was good to have Alan speak before. It works differently. It's not about journals pointing to each other. The way it works is a researcher can come in, sign in, upload their library of citations, right? Their reference library, whether you use EndNote or Mendeley, it makes no difference. So you upload your library, and the next day, this is for PubMed, we're connected to PubMed, we start generating recommendations of new papers based on the authors and journals that you read. We can tell which new papers in PubMed are relevant to you, right? So this is knowledge coming to you. You shouldn't have to search for literature or look at titles of papers. If Pandora can figure out the music you're likely to enjoy, we can figure out, based on your library of papers that you read, what papers are relevant for you, right? So we built PubChase, and then it occurred to us, we have millions of papers in the libraries of our users. When something is retracted, how do you know that one of the 300 papers in your library has been retracted when you're writing a paper and citing things? You don't monthly go and check everything in your database, in your list of references, check to see if perhaps one of the papers was retracted, right? So what we did is we started sending notices. So here, if I do a search, GPR4, we don't just give you back the result, but if we know that it's been retracted, we'll tell you this was retracted, and we will send email to everybody who has this paper in the library from the 2 million papers that we have. We'll send it to everyone saying, by the way, this was just retracted, or there are comments on this in PubMed comments, right? And it may seem like an obvious thing to do, but I'm still not aware of anyone else who's doing this. But this is exactly what a platform like this allows. We're not a journal. We're not a PDF. We know the email of the person, right, who is interacting with the site, so we can send you notifications on protocols or on PubChase. We can send you those alerts. We can send you the notifications. And we also know what you're reading. So when something important is happening on a paper in your library, we know that you want to hear about it. And this, though it may seem like an obvious point, right, this is a potential that we have if you think about the number of platforms like this. So PubChase is a recommendation engine, but these are reference managers, which have the email of the person and their library of papers, right? And so what we have now is, this is going back to Jennifer's talk and some of the things you've heard from Crossref yesterday. Here are all the different things that you probably want to know about. If you have a preprint from bioRxiv in your library, when the final version is published, you probably want to know about it, right? If there was a correction or retraction or a conversation, there are a lot of things that happen to papers that we're pretty sure the readers would like to get alerts on and find out instead of, as I said, randomly colliding with that knowledge. And so the platforms, and this is really the call to action, the platforms are in a really good position to get this information, right? You have a data set on Figshare that is a genome assembly, and 2 years after the paper was published, I, as the PI, now have a much better data set that accompanies that paper. I will put it up on Figshare, but you want that to get to everybody who has been reading that paper and cares about this. And it's never going to happen just between the platforms and all of these different entities that generate information about papers, whether it's discussions or versions, right? Each of these platforms is not going to independently plug into all of the different services, and that's where I think Crossref is so essential. And you've been hearing how important metadata is. It's not just theoretical, it's not just from Crossref's perspective, right? When you register the relationships between the papers, what it allows you to do is it puts us in the position where we can get all of that information to the people that really care about it, right? And going back to the protocols example, it's wonderful we have emails of people. It's fantastic that we can email everyone who has this protocol saying that the author corrected it, or there is a discussion happening on it. But if you think about it, we have 10,000 registered users, right? So we're emailing 0.01% of the people that really care about this particular protocol. These reference managers combined probably have 80 to 90% of the scientists, and they can get that information. So that's the reason we're registering the connection between the protocol and the paper with Crossref, so that eventually you can get there, right? And the last thing that I'll say on all of these, I'm finishing right at 3 o'clock. Yay. The last thing I'll say on all of these, just as you can't expect all of these platforms to individually look up all of the information from these providers, the publishers are in a unique position because the article is at the center, right? The article is at the center of what these platforms have, and the article is at the center with all of the information that relates to it around it as part of that puzzle. So the publishers are in a position to know when there is a protocol accompanying the publication, and you should be registering with Crossref as well. So we at Protocols, we can check all open access literature, but if it's not an open access paper and someone in Materials and Methods puts a link, a DOI to Protocols.io, I have no way of knowing that, and then there is no way of creating this pipeline of getting that information to the readers. So it's both the platforms that should be feeding the updates and the connections to the papers to Crossref and the publishers. And when you do, we can really do something incredible for all of the scientists that are using these platforms. And the most important slide is I just get credit for work that I don't do. These are the people who've created Protocols.io, particularly my co-founder, Alexei, who led the team to build the website from day one. He was on this earlier than me, so 2012 is when he started. We raised money for him to quit his CTO position and start building this. I thought that I could do this on the side while continuing my postdoc. That didn't work out, but he's been on this from day one, and out of nothingness created the mobile apps and a beautiful user experience that we would love for the publishers to connect to. Any questions? No questions? We're tired.
Sorry.
Mark, you shouldn't have any questions. You're Eli.
No,
you know all about it. No, I'm joking.
No, just a little one about the protocol, about the incentives. Because you know, to drive more kind of adoption of the approach and use of people actually registering their protocols and so on, it would be great if they started to get some credit for that when that protocol is being used by tons and tons of people downstream and things like that. Are you aware of any anecdotal sort of examples of that kind of happening, people using you know, that kind of information to support job applications or whatever?
So what we do know is we send monthly reports. We have detailed analytics on all of the rich layer of information of engagement with the protocols. It's not just views, right? We know when people are running it on their phones in the lab. So every scientist has free access to the analytics on their own protocols. And of course, we have metrics, just like at PLOS or any other articles on how many people are viewing it. So it's not, obviously there's no impact factor. We don't do peer review. We're not a journal. But it is very rewarding. Like, we have a lot of people coming back and sharing more protocols. Once we've started sending monthly emails saying 400 people viewed your protocols today, thank you for helping science, you get people to come back and add more protocols. I think there is an intrinsic reward already in academia for making sure that your paper is reproducible, right? If you're publishing a method paper and people can't get it to work in the lab, that's your reputation. So I think we have a lot of incentives. Not everybody will want to share, but I think a lot of the incentives are there. But it is very important to give the credit and to encourage people to do this. Theo?
Yeah, we have one more question and then a quick announcement before break.
Lenny, forgive me if I misunderstood. Jet lag is definitely hitting me today. I think you said, you know, your phone can tell you when the centrifuge is set at the wrong speed or whatever, but wouldn't what you really want is your phone records how long you spun for, at what speed and at what temperature on what day and for how many minutes, and that's your protocol, instead of expecting people to give their kind of average best guess of how they did it.
Well, there are there's several companies that I could name just off the top of my head that are trying to do exactly that. Internet of Things, right? Bringing sensors into the lab, figuring out what condition, humidity of your incubator, of your freezers. So there's a lot happening there, and there's a lot of opportunity for exactly that. There's also robotics that are coming into the lab, and we're starting to talk to the providers of robotics on connecting the protocols to the machine so you can actually just run it with a click of a button. That's still a little bit ways away, right? It's baby steps, but there's a lot of really exciting stuff that we can do with the technology that we have today. I know we're late. Let's have a break, and I'm here and happy to answer any questions.